Hello everyone. I hope you're all doing good. In this video, we are going to study about the rational numbers and properties of rational numbers. Example for rational numbers. What is additive inverse? What is additive identity? Multiplicative identity, multiplicative inverse. So before going to the rational numbers, let's see the few types of numbers. First is natural numbers. Natural numbers represents with capital letter N. N equals, it will start with 1, 2, 3, 4 and so on. Second type of number is whole number. Whole numbers represents with capital letter W. It will start with 0. W equals 0, 1, 2, 3, 4 and so on. Next type of number is integers. It is represents with plus or minus z or plus or minus I. So, including 0. Plus or minus I equals 0. In the right hand side, we'll write all positive numbers. In left hand side, we'll write the negative integers. Then fourth type is rational number. Rational numbers is represents with capital letter Q. It is in the form of P by Q. And condition is Q is not equal to 0. If P and Q are integers. So definition of rational number is if P and Q both are integers and Q not equal to 0 are called rational numbers. Next, example for rational numbers: minus 3 by 5, 0 by 1. 0 is also a rational number. 1 by 2. You can write positive and negative rational numbers. Next is properties of rational numbers. Rational numbers, first property is closure property. Next heading is properties of rational numbers. We'll see one by one what are the properties of rational numbers. So even in the whole numbers also we learn property, closure property, commutative property, associative property, distributive property. Same properties we are going to apply in rational numbers also. Check whether those properties are holds good or not. Let's see, the first one is closure property. What closure property will say here? If two rational numbers are added together, the result, what we'll get the answer is again a rational number. If two rational number are added together, the result is always a rational number. Let's see the few examples whether this property is holds good or not. Take any two rational numbers. I'm going to take 3 by 4 and 1 by 2. So if you add any two rational numbers, again the results will be rational number. 3 by 4 plus 1 by 2. When you have a fractions form in addition or subtractions, you should take LCM for the denominator numbers. 2 and 4, let's take the LCM. 2 ones are 2 twos are 1s are 1s are. The LCM is 4. Write the 4 here. Divide 4. Divide 4. LCM numbers you should divide in the denominator. 1s are 2 1s are 2 2s are. 3 1s are 3. 2 1s are 2. So we'll get 5 by 4. Yes. 5 by 4 is in the form of P by Q. Correct? So P by Q we call it as rational number. The closure property is holds good for the addition of the any two rational numbers. The result is also a rational number. Okay. Let's see the next property is commutative property. The addition of any two rational numbers is commutative. For example, here we are going to generally consider A by B and C by D are two rational numbers. So addition of rational numbers here, A by B plus C by D. Taking the reverse order, C by D plus A by B. This is commutative property in rational number. Okay. Now we'll take the examples. Let's take 1 by 2 and 3 by 4. You can take negative also. So for A by B represents here 1 by 2. C by D represents 3 by 4. 1 by 2 plus 3 by 4. And here 3 by 4 plus 1 by 2. If fractions additions comes, you should take the LCM. For 2 and 4, LCM 2 1s are 2 2s are. Again take 2 1s are 1s are. The LCM is 4. 4 and here also we'll write 4. Let's divide the LCM in the denominator. 2 1s are 2 2s are. 4 1s are 4 1s are. 2 into 1 is 2. 1 3s are 3. Let's divide the same. 1 1s are 1. 4 1s are 4. 2 1s are 2 2s are. 3 plus 2. So we'll get 5 by 4 and 5 by 4. Commutative property in rational numbers, it is holds good. Sorry, LHS is equal to RHS. Third property is associative property. For associative property, you should consider 3 rational numbers. Any 3 rational numbers. Generally, we are going to take A by B, C by D, and third one is E by F. 3 rational numbers. We are taking A by B, C by D, E by F. Associative property is A by B plus C by D E by F equals in the RHS A by B, C by D, E by F. Let's group this first two terms and last two terms. This is associative property in addition of rational numbers. Let us consider the example 1 by 2, 3 by 4 and 2 by 3. Let's substitute in the property here. 1 by 2 plus 3 by 4 is 2 by 3, that is equal to 1 by 2 plus 3 by 4 plus 2 by 3. First we should simplify the bracket inside the bracket terms. For addition of, when additions comes, we should take the LCM. For 2 and 4, LCM means 2 ones are 2 twos are 2 ones are ones are. So LCM is 4. And for 4 and 3 also we should take the LCM in the left right hand side. 3 as it is 2 ones are 3 ones are 12. 2 twos are 4, 4 threes are 12. LCM is 12. Write the LCM 4 here. Divide the 4. 2 ones are 2 twos are 4 ones are 4 ones are. 2 into 1 is 2. 1 threes are 3. 2 by 3. 1 by 2 plus, here write 12. Divide by 12. 4 ones are 4 threes are 3 ones are 3 fours are 3 threes are 9. 4 twos are 8. Then get 5 by 4. 2 by 3. 1 by 2 plus 3 threes are 9. 9 plus 8 is, you will get 17. 17 by 12. 4 and 3 we already calculated the LCM. We will take directly 12 here. So again we should divide the 12. 4 ones are 4 threes are 3 ones are 3 fours are 3 fives are 15 plus 4 twos are 8. And for here 12 and 2 LCM we should take. I'll write it here. 2 ones are 2 six are 1 as it is 3s are 12. I have 1. The LCM is 12. Divide the 12 in the denominator. 2 ones are 2 6 are 12. 12 get cancelled 1. 6 plus 17. 15 plus 8. So we will get 23 by 12. So 70 plus 6, here also will get 23 by 12. Therefore, LHS is equal to RHS. So associative property is holds good for the rational numbers. Okay. So remaining properties we will discuss in the next video.